In this video, we are going to identify management tools for non-relational data and describe provisioning and deployment on Microsoft Azure. In this video, we're going to have a look at some management tools for looking at Cosmos DB. And I've gone to a website called gotcosmos.com/tools. So you can see there are lots of different tools. Free here, another free down here. So a Cosmos DB emulator allows you to develop and test your application on your own computer. You can also get it for Visual Studio for the coding extension. Now the Azure Storage Explorer, it's now a bit deprecated. It's no longer the one you should necessarily use. So if I have this on the left-hand side and I have Azure Storage Explorer on the right-hand side, then if I go into my Cosmos DB account and go to keys, you'll see we've got all of these keys, and here we have a primary connection string. So I'll just copy that into the clipboard, and now I'll connect to Cosmos DB in here. So I'll just paste my connection string, and here I've now got connection to my database with its documents. So this is how you can connect to Cosmos DB using the Microsoft Azure Storage Explorer. You've also got Azure Database Migration, including the Database Migration tool. So this is good if you are importing data from JSON files, from on-prem MongoDB, from SQL Server, also by Microsoft, comma-separated value files, Azure Table Storage, Amazon, DynamoDB, HBase, and Azure Cosmos Containers. So lots of ways to get data, just one tool needed. Now, actually, this tool is fairly well designed for the smaller importing. This is what it looks like. So you can see, use this to import data in a variety of sources. So you put in your source information. So here we have your import from, your target information, including your connection string and your collection and partition key is appropriate. And then if you want an error log file, you're able to get that as well. So this is how you can import data into Cosmos DB. But if I look up more details about this particular tool, you'll see that this data migration tool, easy to set up, supports multiple sources, but not suitable for large data sets. So if you do have any bigger data sets, there are alternatives to use, such as the Azure Data Factory, which is suitable for the injection of large data sets. And you can see still supports multiple sources. We'll be looking at the Azure Data Factory later on in this course. So there are other tools you can use, like for instance, the bulk executor library. There's also the SQL API client library. So if you are able to code, that is very useful as well. Though two big tools that I haven't mentioned, we've been using all the way through. You can use the Azure portal at portal.azure.com, and you can also use the Azure Cosmos Explorer at cosmos.azure.com. So there are lots of different management tools that you can use for semi-structured data with non-relational data, such as the Azure portal, the Cosmos Explorer, the data migration tool, the Azure Data Factory, and various libraries such as the bulk executor and the SQL API client. Hello, in this section we are stepping back from semi-structured data and non-structured data and looking at the entirety of the non-relational data services to answer specific questions in the DP 900 exam. The first one is describing the provisioning and deployment of non-relational data services. Well, we have done a lot on this. So what you do is you specify the type of service, including the API. You specify whether it's provisioned or serverless. You specify, where appropriate, the memory and the compute power. You specify the amount of throughputs. So these are the request units per second. And you can do that at a database or at a container level. And you can also specify whether you have dedicated throughput for the one service or whether you have a shared throughput. So you might have multiple databases using the same share. And then once you've done all this, then Azure just takes it all behind the scenes without any further input once you have reviewed and created everything. Now, there are a few facets to these, and if I look at the Cosmos DB to start with, we can talk about the different replication options. So you can replicate data globally, as we've discussed. So by default, it is replicated to another region, but of Azure's own choice. Additional regions, which increase the price, can be selected. These will be read-only replicas by default, unless you enable asynchronous multi-region writes at an additional cost. So what is asynchronous? It means that I can write in one region and it then transfers to the other regions. Now, how much do you want all of the regions to agree with what the right data is? Well, this is when consistency comes to mind. So you have, for instance, session consistency. This is the one in the middle. So this means that if an individual user, say, is in UK South and writes to UK South and then reads from UK South, then they will still get exactly what they have written. However, if that individual user or somebody else was to go to, say, Australia East, there might be a bit of a delay, which is not necessarily critical. You have to decide how critical any of these things are. If it's really critical, then you need strong consistency. So this shows that data is only available when it's written everywhere. So it's all synchronized. But sadly, it does cause the most latency because you have to write it in one place and then make sure it is written in another place. And you can see the average latency there, 1/4 of a second, 255 milliseconds. So it's got to get to Australia. It's got to be written. It's got to be confirmed as being written. It's got to go back to where you started from. Same with everywhere else that you write before everywhere goes, okay, we've written it. Everyone can read it. There are ones in the middle, like boundless staleness, consistency, and consistent prefix. So that ensures that everything is in the right order. And then we have eventual, which gives the lowest latency but the least consistency. So you have to choose which of these: strong, data only available when written everywhere; boundless staleness, there's a lag between writing and reading; session, so your own session will have your own rights; constant prefix, it will always be in the right order; and eventual, it's just written whenever is best for you. Now, for this particular exam, you probably won't need to know that there are all of these different types of consistency, but you will need to know what consistency is and how to set it. So you go to the default consistency. If we now have a look at storage accounts, we can see that in the configuration section, you can select the default blob access tier, whether it's hot or cold. Hot has greater storage costs, but lower access costs. Cool, the other way around. Archive is inaccessible until rehydrated. You can override the default blob access tier for individual blobs. You can also say how it's replicated, and again, not all replications are available. Premium, for instance, generally does not have the geo-redundant storage. It might have zone-redundant storage, ZRS, but not geo-redundant storage, GRS. LRS is the default. It just gets written 3 times to the local area. And then we have Active Directory integration. So do you have to log in to Azure AD, like I am here, I'm logged into the portal, to access these file shares? Going to encryption. So by default, Microsoft manages the keys, so it's all behind the hood. It is not something that you necessarily need to interfere. However, if you do need to put something in, you'll say you have your own policies which require you to have your own keys, then you can do this. It goes into the Azure Key Vault. But as you can see, storage service encryption protects your data at rest and is automatically encrypted and decrypted when you access it. And then finally, shared access signatures. This is a unique resource identifier. So you can think of something like, for instance, up here. This web address is a unique identifier to this particular website. So it's a unique identifier to grant restricted access to certain resources, and it's restricted in the sense of a specified period of time. So you can say they can have access to a particular resource for a particular time, and then it automatically lapses. So these are some of the details behind the provisioning and deployment of non-related data services. In the next video, we'll have a reminder maybe, of some of the methods for deployment. Well, I hope you've enjoyed this video. This video was previously part of our DP900 Microsoft Azure Data Fundamentals course. If you would like any help studying for this exam, then please go to our website, idodata.com, and find out more about our video course on this exam. We've also got video courses on the AZ900 exam and many other exams. We've also got video courses on SQL and other topics as well. If you would like similar videos to this one, then please click on the link on the end screen. And if you like this video, please click on the like, and why not subscribe and click that bell? That way you'll be notified of any new videos. I'm Philip Burton of idodata.com. Thanks for watching and keep learning.